bitches, that's my fucking problem. Yeah, I like to fuck, I got a fucking problem. I love bad bitches, that's my fucking problem.
So just a warning, this one's kind of a doozy, and then it has kind of a bit of work to be shown, but once you get the concept, then we'll be good. So we're given the following infinite series, and starts at 1 and then goes up to infinity of 1 over n times n plus 3. So we're told that this is a telescoping series, and telescoping just means, telescoping series just, well, to me it means that some terms can cancel out, some terms in the middle can cancel out, some terms cancel out. Okay, so that's what we're going to be expecting, for some terms to cancel out. Alright, so let's see. So we could start by calculating the partial sums, like starting with s sub 1, s sub 2, s sub 3, and then seeing what they come out to be. But I'd like to start with using the method of partial fractions, if you remember what that is. Remember the a and b thing? So I'm going to break this up into something over n plus something b over the second denominator, right? Remember this. So this has to equal 1 over n times n plus 3. So I'm going to do the numerator trick. So we have a times the other denominator, right? We ignore the n below it, but we multiply times the other denominator, plus, now we're looking at b, so we ignore this part, and we just consider the n here, equals, and the numerator of the other, so that would just be 1, or 0n plus 1, right? So then we have a plus b times n. Now I'm just kind of rearranging, okay? And so a plus b must equal 0 when we compare the coefficients of n, and then 3a must equal 1 when we compare the constants. So a has to equal a positive 1 over 3, therefore b equals a negative 1 over 3. Okay? So this just means that we can rewrite our sequence as 1 over 3n, because now we have a over n, and then plus, which is now a minus 1 over 3, because b is negative 1 over 3, times n plus 3. Okay, so from here, I'm actually going to take out the 1 over 3 to make it a little bit simpler. So we just have 1 over n minus 1 over n plus 3. Okay, so this is just a different form of what we have here. Alright, I just transformed that into this. So it makes it a little bit easier to calculate. In a sense, I guess you can call it decomposed what we started with, so that for each term we have 2 terms, and there's more possibilities for terms to cancel out. Okay, so on the next slide, well, alright, so I'll explain a little bit. So this allows us, by decomposing it, it allows us to expand the terms and then find a pattern. So that was the whole point of me doing the partial fractions thing. So we can expand out the terms and find patterns. Find patterns. Okay? That was the important part there. So in the next one, I'll use this formula, this formula here, to find our partial sums, and then we'll try to find a pattern in them. Okay, so again, here's a refresher if we need it. 1 over n plus 3. So this is our an. Okay, so let's do the first partial sums. So we have 1 over 3, and then we're just going to plug in a 1 for n. Or, wait, whoa, that is a minus sign. Minus 1 over 1 plus 3. And this comes out to be 1 over 3 minus 1 over 12. Okay, and you can check by yourself, but I'm just going to write all of the partial sums here so that we can kind of save time. So I'll just show the final result kind of thing. So s sub 2 would be a1 plus a2, right? So I'm just going to write this a1 here. And then the a2 part turns out to be 1 over 6 minus 1 over 15. Okay. And then I'll just write, I'm going to write quite a few so that we can really see the pattern, and it'll be easier to identify. So these are the first two terms, and then we're going to add on the third term, which turns out to be 1 over 9 minus 1 over 18. And I'm going to actually group these together so that it's easier to see. So each group of parentheses, so like this first one, S sub 1, this is technically this is A1, okay? And then here's our A1 again, and here's our A2. So this second part here is A2. So then in the S sub 3, we have A1, A2, A3. And continuing, we have the same. So as of now, as I said, telescoping series is supposed to, it's kind of made or constructed, or I don't know, I guess it's constructed so that some of the terms cancel out. But as of now, I don't really see any cancellations. So we're just gonna, at this point, we just need some patience. I don't really know what else to say about that, but it's because the 3 here, the n plus 3, that means that canceled or potentially canceled terms will only occur every 3 terms, I believe, something like that. So then the fourth term, a sub 4, is 1 over 12 minus 1 over 21. So this is an important step here, because now we see a positive 1 over 12 that is able to cancel with a negative 1 over 12. So I'll write a little faint line here. So that'll eventually cancel out. And then I'll write 2 more partial sums so that we see the real pattern that's going on. Okay, I'm going to try to write fast here so I don't waste your guys' time. Plus 1 over 9 minus 1 over 18 plus 1 over 12 minus 1 over 21. And here's the new term. Now we have a plus 1 over 15 minus 1 over 24. Okay? And again, this is really good. Well, the 1 over 12s cancel, obviously. And then we have the negative 1 over 15 and now a plus 1 over 15. And I'll go with one more. And then that'll be pretty good. Plus 1 over 6 minus 1 over 15 plus, bear with me here please, plus 1 over 12 minus 1 over 21 plus, okay, I'm going to fit this. Wait for it. And then our final term here is going to be a plus, and you might guess it's a 1 over 18. And then the next one is 1 over 27. Okay, so on this last one here, we can see that the 1 over 12, the negative 1 and the positive 1 cancel out. The negative 1 over 15, positive 1 over 15, negative 1 over 18, positive 1 over 18. So what we actually get, and I'll just write it up here so I don't have to go into the next slide yet, but then our S6, S sub 6 equals 1 over 3, right, plus 1 over 6 plus 1 over 9, and then we start going into the minuses. So then we get minus a 1 over 21 minus 1 over 24 minus 1 over 27. So you might see that it's useful to factor out a 1 over 3. So then this might be a little bit more recognizable. So then if you factor out a 1 over 3, we get 1 plus 1 over 2 plus 1 over 3. And then we have a minus 1 over 7 minus 1 over 8 minus 1 over 9. Okay? So here, this is our first term, technically. This was when n equals 1. This was when n equals 2. This was when n equals 3. This was when n equals 4, n equals 5, and finally n equals 6, right? Because we went up to the 6th term, okay? And then this 1 over 3, that's kind of just a constant in front. So what we can say is that, well, basically, okay, so the whole concept behind this is we're finding the infinite series, or the sum of the infinite series, so as n goes to infinity. So these 3 terms in front, which you can also see here, well, I'll highlight them down here. So I'm boxing the terms that stay in the series as n goes to infinity. These 3 are never going to be canceled out, okay? So that's the same as this, right? But as n goes to infinity, we're going to have more negatives added on. So we need to find a way to kind of generalize these terms, okay? And I will do so on the next slide. So as I was saying, we have something like this, right? Plus 1 over 3 minus, and this is a negative 1 over 7, minus 1 over 8, minus 1 over 9. And then etc. As n goes to infinity, then we could just assume it's going to be negative 1 over 10, negative 1 over 11, etc. But the way this was n equals 4, right? That's what we said. This is the 5th term, and this comes from the 6th term. So we can actually rewrite this as the following. 1 over 3 times, and then these first 3 terms just stay the same, as I said in the previous slide. And this is the same as, you could probably agree that 7 is 3 plus 4, right? 8 is 3 plus 5, and 9 is 3 plus 6. Okay, so what we actually have here is something like this. Okay, this is going to be the general way to write all of the following terms after as n equals 4 and above. Okay, so what we can conclude from that is that this is our general form. So general form. Okay, so now we're just going to find the limit as n goes to infinity of this general form, which is now 1 over 3 times 1 plus 1 over 2 plus 1 over 3. And these ones, as I said, these ones don't have n's in them or anything because they're going to remain constant and untouched, basically, as n goes to infinity. Okay, then we have our minus 1 over n plus 3. This is the thing that changes as the 7, 8, 9, 10, 11, and etc. So we're just going to calculate this, and as n goes to infinity, we can tell, well, okay, I'll rewrite it down here. 1 over 3, 1 plus 1 over 2 plus 1 over 3 minus, and now we're going to plug in the infinity. So this term here just goes to 0. So our final answer is going to be something that looks like this. So 1, I'm just going to rewrite it as this to get common denominators, plus 2 over 6. And that's just going to be 11 over 18. So this is the sum of our infinite series. Okay?